Hi there and welcome back to another Papetti Math YouTube video tutorial where today I am going to be teaching you, yes you, Algebra 1. And in this video we're going to be taking a look at exercise number 3 in lesson 5 on exploring real life scenarios. And this exercise says a catapult is designed to fire projectiles a certain height based on quadratic equations that are programmed into it. Shirley, Ava, and Oliver each believe that they have found a quadratic equation that will allow the catapult to reach a maximum height of at least 275 feet. Determine whose equations are capable of reaching a height of at least 275 feet. So we're going to be finding our maximum heights 3 times here. And to do that, what we're going to be doing is we're going to be using our axis of symmetry formula. So we're going to start off with x equals negative b over 2 times a. And we know that our b value for Shirley is going to be 126. So let's make that negative 126 because it's negative b. Divided by 2 times a, and a is going to be negative 14. So now we're going to have negative 126 divided by negative 28. And negative 126 divided by negative 28 is going to be positive 4.5. So we're going to take that and we're going to substitute that 4.5 into the equation and get negative 14 times 4.5 squared plus 126 times 4.5. And we're just going to put that whole thing in our calculator. We're not going to waste any time here. We're going to put that entire thing in our calculator and we're going to get it looks like 283.5. And that's going to be feet. Now, is that at least 275 feet? At least 275 feet? The answer is yes. 283.5 feet is at least 275 feet. So Shirley's equation works. So now let's go on to Ava's equation. And we're going to go back to using our axis of symmetry formula. We're going to have x equals negative b divided by 2 times a. And we're going to have negative 92 because our b value is 92, divided by 2 times a, which is negative 8. And we're going to have negative 92 divided by negative 16. So when we divide those two numbers, we're going to get a positive 5.75. Now let's substitute in that x value into our equation to find our vertex, and we're going to have negative 8 times 5.75 squared plus 92 times 5.75. And when we substitute all that in and put that in our calculators, we're going to get a total of it looks like 264.5. And 264.5 feet is not at least 275 feet, so Ava's equation is not going to work. Which brings us to our final equation, which is Oliver's, and we're going to do that same thing one more time. We're going to use our axis of symmetry formula to start, which is negative b divided by 2a. We're going to have negative 57 divided by 2 times negative 3. That's going to be negative 57 divided by negative 6. That's going to be 9.5. So we're going to substitute 9.5 in for x now to get our maximum height and see if it's at least 275 feet. So again, we have negative 3 times 9.5 squared plus 57 times 9.5. So we're going to put this in our calculator. And we're going to get a maximum height of 270.75 feet. And 270.75 feet is not at least 275 feet. So again, Oliver's equation is not going to work either. So whose equations are capable of reaching a height of at least 275 feet? And that's going to be Shirley's equation. That is the only one that reached a height of at least 275 feet. Now, if this video was helpful in explaining this problem, please give it a thumbs up, and you are now ready for exercise number 4. Thank you for watching.